Okay, this is 9.3, the greenhouse effect. So by the end of this lesson, you should be able to identify the greenhouse gases and identify the sources and potency of the different greenhouse gases. So let's start by talking about what the greenhouse effect is by looking at solar radiation. So it's important here to see that not all incoming solar radiation reaches Earth's surface. And this is a very good thing, because that would be very bad for us if it did. So when we're looking here, we see we have the sun coming in, the atmosphere is having some of it bounce off, and some of it is making through, which is giving Earth a nice, warm, happy place to live. So we see that 26% of the incoming sunlight is reflected back into space by the clouds in the atmosphere. So we see this being reflected back into space. Then we see that 19% of it is absorbed by atmosphere and clouds, some of which then gets radiated out into space, and the rest comes down here to Earth. So the incoming solar radiation, remember the term insolation from Unit 4, reaches Earth's surface where it is absorbed or reflected depending on the albedo of a surface. So we've been throwing the word albedo around when we talked about the different surface materials in housing. So albedo is the amount of sunlight which is reflected off of a surface. So light-colored surfaces have a high albedo because a high percentage of sunlight is reflected back off of it. Dark surfaces have a low albedo because a low amount of sunlight is reflected off of the surface. So this is important when we're talking about our global heating and cooling cycles of the Earth. High albedo things might be clouds and ice. Dark things will be oceans, blacktop, soil. These things are going to absorb heat. So the greenhouse effect. The greenhouse effect is when the gases in Earth's atmosphere trap heat from the sun and radiate it back down to Earth. First, I want to start with this important point. The greenhouse effect is not bad. It's neither bad nor good. It depends on the context and how much of it. So without the greenhouse effect at all, Earth would be too cold to support life. So Earth is 60 degrees Fahrenheit. Without the atmosphere, it would be 0. We would not be happily living here. Plants would not be growing. It would not support life on Earth. So what exactly is happening with the greenhouse effect before we look at what happens when we have a runaway greenhouse effect? So the energy from the sun is coming in as UV light and different wavelengths, but mostly UV light. So this is coming in from the sun like this. So this is higher frequency because it's more energy. What it does is it strikes the Earth, it gets absorbed, and then re-radiated as lower frequency infrared radiation, so heat. After it hits Earth. So when this stuff gets re-radiated, the energy gets re-radiated back into Earth, this is what's heating us up near the ground. So it's giving us warmth near the ground. Then there's molecules in our atmosphere, our greenhouse gases, where this re-radiated energy hits them and then gets bounced back towards Earth, or hits them and gets re-radiated back out into space. This is what creates the general idea of the greenhouse effect. Some is escaping, some is getting trapped and re-radiated back towards Earth. So greenhouse gases hold the heat in the atmosphere. Think of it like a nice sweater holding heat in against the Earth. What the problem is when we meet our friends, the greenhouse gases, when there's too many of them. too much of a good thing. So some greenhouse gases are needed to keep our atmosphere warm enough to live, but too many is re-radiating too much heat back towards Earth. So here are the 5 main greenhouse gases. So I'm going to come back to water vapor in a minute. Let's start with nitrous oxide, so N2O. This comes from agricultural soils, so in the process of denitrification, we get nitrous oxide, and we see this in overwatered or over-fertilized soil. So coming from our agricultural sources. We're all familiar with our friend carbon dioxide, which comes from fossil fuel combustion. It comes from decomposition, gets released in deforestation. We've recently met the fluorocarbons, chlorofluorocarbon and hydrofluorocarbon. These come from refrigerants, things that keep our food cold. Blowing agents and aerosols, so hairspray. And then we've got methane, which comes from natural gas extraction, animal agriculture, cow burps, cow farts, and anaerobic decomposition, which we see when our permafrost is thawing. So here are the big 4 greenhouse gases. And then last but not least, we have water vapor. By definition, water vapor is a greenhouse gas, but it doesn't act like a greenhouse gas. Water vapor comes from evaporation and transpiration in plants, evapotranspiration. But the difference here is these things all increase temperature. Water vapor increases because of an increased temperature, not the other way around. So these 4 gases are causing the temperature to increase. This water vapor increases because of the increase in temperature. It's also relatively short-lived in the atmosphere, so it's not really hanging around to cause a lot of problems. So global warming potential. This is a measure of how much a given molecule of gas contributes to the warming of the atmosphere. And this is based on a 100-year period using CO2 as our standard. So we base the others off of how they compare to CO2. To compare them, we use the residence time, how long they stay in the atmosphere, and then the infrared absorption. How well do they absorb and radiate infrared radiation, which is that lower wave light energy that produces heat. So again, CO2 is our standard. So it has a global warming potential of 1. That's what we compare everything else off of. Then we have methane. So we're moving down this way. Methane has a global warming potential of 23 to 84 because it remains in the atmosphere for 12 years and absorbs more infrared radiation than CO2. Then we get to nitrous oxide. So this is our agricultural soils. It has a global warming potential of 300 and remains in the atmosphere for 115 years and absorbs much more infrared radiation than CO2. Last but not least, we've got our big problem here, which is the CFCs. They have a global warming potential of 1,600 to 13,000. They remain for 50 to 500 years and absorb much, much, much more infrared radiation than CO2. So remember when we talked about the global, the ozone hole, the issue was that these chlorofluorocarbons stay for so long, even though we've stopped using them, we still see them there because they're not leaving. So CO2 is bad. Chlorofluorocarbons are very, very bad. So to summarize, the greenhouse gases carbon dioxide, methane, water vapor, nitrous oxide, and chlorofluorocarbons. Water vapor doesn't contribute significantly to global climate change because it's so short, so we kind of don't talk about that one as much when we're talking about the big bad guys. The greenhouse effect is necessary to maintaining a temperature suitable for life on Earth, so don't write that the greenhouse effect is bad. It's not. We need it. And chlorofluorocarbons have the highest global warming potential, followed by nitrous oxide and then methane. So these are our big top 3 problem children.